All right, day 2 here. So the second day of work is just with volumes. So just remember for the volume of a prism or the volume of a cylinder is essentially just the same thing. As long as our shape has two bases, remember bases are parallel and congruent sides. So you can see in the first shape, our base would technically be considered this rectangle or square on the bottom. So there's two of them that are parallel and congruent. Here we'd have a triangular prism because we have these two triangles that are parallel and congruent. And then the height is the distance between those two bases. All right. If it's a cylinder, okay, we have a circular base, two of them, and then the height in between them. And so the area formula is just the area of the base times the height. Here it's a circle, so it's pi r squared h. And here it's either going to be like base times height, or length times width times height, or the 1/2 base times height for the area of a triangle times the height of the prism, just the area of the base times the height. So for number 1, if we want to find the volume, we would treat our base here as the bottom. And so the volume would essentially be like, if you want to think of this as length times width, this is length times width times height. So it's 7 times 4 times 3. 3 is the height because we can see the perpendicular line here. And that would mean the volume is going to be essentially 12 times 7. So that's 84. And then yards cubed because we're doing yard. 7 yards, 4 yards, 3 yards. So yard times yard times yard. Shape number 2 is a trapezoidal prism. So the area of the volume formula, we say it's the area of the base. That's a capital B, represents the area of the base, times the height. And then we have to input the formula. So it's 1/2 the area of the base. So this is actually a little bit, the 1/2 starts off the area of the base times the height of the trapezoid times the sum of base 1 plus base 2. And then we're going to multiply this times the height of the prism. So I'll do a capital H for the height of the prism. So here it's 1/2 times 1.5 times the sum of 2 plus 4, and then times 6. And so we would want to bust out a little calculator action for this one if you needed to. We can just type this right in for ourselves. Let's make this pause for a second. And so this is going to end up equaling 27 centimeters cubed. And then you're just going to keep going from there. So here we have we're going to just say that this is 14 here for our height. So the area of the basis is for a cylinder is pi r squared times the height of the prism. So pi, the 11 represents the diameter. So 5.5 would represent the radius, and then times 14 squared. And then we would want to use the pi button on the calculator here. So let me get that up for you guys so we can see where it is. All right, so on the calculator, on the bottom left-hand corner next to the H button, there's the pi button right there. So for our calculation here, we're going to go ahead and do pi, so times 5.5 squared. So pi, select the button, then we click on pi. You can do parentheses, and then 5.5, and we can close it off, squared, and then times 14 for our height. And we are going to get that for our answer. And we're rounding to the nearest hundredth. So there's 2 zeros and 100. We're going to round to the second decimal place. So thousands has 3 zeros. We go 3 decimal places. 10 thousandths, let's say, would have 4 zeros. You know, if it's 1 millionth, that would have 6 zeros. That's how many spaces you round to. So it's 1,330.46. 1,330.46. And then inches cubed here. All right. On the next page here, we have 2 other shapes we're going to talk about. One is a pyramid, and the other one's a cone. The volume formula, though, is essentially going to be pretty much the same, where it's the area of the base times the height, except now it's just 1/3. So you can imagine and you can kind of picture that if we put this in a box, we would have this extra room here around the shape, and that actually would make up the pyramid would take up exactly 1/3 of that space. Likewise, the cone we would place inside of a cylinder, and the cone takes up 1/3 of that space. That's essentially where those formulas are coming from. So remember, the formula for the volume is 1/3, and then it's the area of the base for the pyramid times the height. So in this case, it's 1/3. It's 8 times 8 for the square, and then times 10, which is like if I dropped a rope down from the very top of the vertex point at the top, that would make a length of 10. And I believe this is going to be 100. Well, we'll see. So it's 8 times 8 times 10, and then 1/3 of that, 8 times 8 times 10, and then divided by 3. And we are going to get a crazy looking decimal here in a second. So it's 213.3 repeating, nearest thousandth. So 213, thousandth has 3 zeros. So I know it's going to end in 0.333. All right, same thing here. We want to figure out what x is here. So we're going to start with our volume formula. So we're just going to do 1/3 the area of the base times the height. And then I'm going to plug in. So I know the volume is 15,000. That's going to go in for V. It's 1/3. I do have the 2 lengths of the base. So 15 times 15. And then x is our height. So we'll actually combine the 1/3, 15, and 15 first and see what we come up with here. So 1/3 times 15 times 15, and we get 75. So we can simplify that to just 75x, and then we can just divide this by 75. And I believe we should get 20 for x, but we can figure that out. So there we go. And we're good to go. Okay. Same thing on the next one. The volume is going to be 1/3 pi r squared, because the area of the base is a circle, times the height of the prism. Here we don't know r, so we're going to plug in 8 pi for volume. We're going to plug in 1/3 pi. We're going to leave this as x squared, and we're going to multiply this times 6. So we are going to combine like terms. We can combine the 1/3 and the 6 to get 2 pi, and then this is x squared. We want to get the x squared by itself, so we'll divide out by the 2 pi on both sides. So the pi's are all going to cancel. The 2's are going to cancel, and 8 divided by 2 is 4. That's equal to x squared. And then to undo the squared, we need to take the square root. And the square root of 4 is 2. And so we're left with this. And it does say nearest tenth, so we'll put 2.0 down, since we are going to the nearest tenth there. Spheres, just one easy formula, 4/3 pi r cubed. So it's kind of like pi r squared, but we're doing the 4/3 and then r cubed. So this circle that's inside the sphere, like if you cut the orange in half, is referred to as the great circle. If you moved a little bit up or down, you would get a smaller circle. So it's the largest circle you can create inside a sphere, kind of like the equator on the Earth. And the radius of this circle is the radius of our sphere. Okay, so snow globes consist of the grass sphere. If it's completely filled with liquid, no air bubbles or anything inside, you know the radius, okay, is a length of 3 inches. We want to know the volume. So volume is 4/3 pi r cubed. So 4/3 pi r, once again, is 3 to the 3rd power. Now it doesn't say what to round to, so we can just use in terms of pi here. So 4/3. We're not going to do the pi button this time. We would normally do pi, but since it doesn't say what to round to, and then we're going to do skipping that times 3 to the 3rd power. Okay, and we're probably going to want to put times in there. So we're going to get 36 and then pi. This is our exact answer. If you wanted to go ahead and do times pi here, you can get the, there is our decimal answer. And then we could say it's about 113 because it says approximate. So it's approximately 113. All right, and then this is inches cubed for the value. All right. And that is it for that one. So I hope you guys enjoy the rest of your break here. We'll see you in a couple days. And then close it out. So we'll be going into quadratics next. So come back Monday. We'll take a look and finish up some more volume questions. And then we'll get into some quadratics and factoring and stuff. So, all right, guys, have a great one. Enjoy the rest of your time off.